Okay, so we are now in section 10.5, and we are going to talk a whole lot about angles today. So these are angles related to a circle. And I'm going to do my best to give you a nice little summary page or a little condensed notes that you can look back at once after we've explained everything. So remember back to when we first started talking about angles, and we used the angle right here where the vertex was in the center of the circle, and this was called the central angle. Central angle here. So the vertex was at the center, and then there was the arc here. This was called the intercepted arc. And so the angle measurement and the arc measurement were exactly the same. Now we're going to put the vertex on the circle. So we are going to do what's called an inscribed angle. So that looks like, let's say our center is here, and so we have two chords, and the vertex is on the circle. So this is what's called an inscribed angle. Inscribed is not a new word, we've used it a lot. And this is still the intercepted arc. Intercepted arc. Okay, in this case here, we said the central angle measure, I'll put a little m for measure. Measure of the central angle is equal to the measure of the intercepted arc. In this case, however, the inscribed angle is equal to half of the measure of the arc. So half of the measure of the arc. So let's put some letters on here, and we can, this is A, this is B, we'll call this C. And so angle ACB equals half of arc AB. That's how that works. There's another situation where the vertex will be on the circle, and that would be, oh, that's a terrible circle, isn't it? Maybe I'll have to redo that. There we go. Okay, so we have a chord, and then we have a tangent. So this is just called a chord tangent angle. But it behaves exactly like the inscribed angle. So if we did A, B, put B on there, and C, it would still be angle ACB is equal to half of arc AB. So these two behave the same way. The vertex is on the circle, so the angle measure is half of the arc measure. Okay, so let's say that our vertex is now off of the circle. So let's do two secants. We'll do, let's see, circle, and we'll do a secant and a secant. So now the angle measure is off. I'm sorry, the angle measure, the vertex is off. This is a secant angle. Okay, we have we have two intercepted arcs. We have, this is AB, so this arc is intercepted, and then we have arc CD, this guy here. And then we'll call this point P. So we have this angle P, and then we have arc DC and arc AB. So angle P is equal to half of the difference of the arcs. Make sure that you do large arc minus small arc. Okay, so the vertex is on the outside, so the angle measure is equal to half of the difference of the arcs. There's another situation where you could have the angle on the outside. You could have two tangents. We'll call that A, B. We'll put a C out here, and we'll call that point P. Okay, same thing. Angle P is equal to half of the difference of the arcs. So you've got this major arc here. So you have arc A, C, B. And then you have your minor arc here minus arc AB. So it's the same thing. And then there's one more setup. You could do a this is a tangent angle. Tangent angle. And then the last setup would be a secant tangent angle. So you could do like so. Here's a secant, and then there's a tangent. So we could call this A, B, C, and then that's point P. It's the same thing because the vertex is on the outside of the circle. So angle P is equal to half of the difference of the arcs. So large arc, arc AB, minus smaller arc, arc BC. No big deal. Okay, so let's do a situation. We did arcs on the circle, right? Arc on the center. We dealt with that in the very beginning of the chapter. Then we talked about angles. I'm sorry, not arcs, angles. Angles in the center, central angles. Angles where the vertex is on the circle. This is angles where the vertex is outside the circle. Now let's do inside the circle. And so we're going to have a chord angle. All right. Here we go. So it looks like, here's our center. We'll do a chord here and, a chord here. Oh boy, you can't see very well, can you? Chord angle. And we'll label some things. Let's say this is A, this is B, this is C, this is D. And where they intersect, we'll call that E. There's actually 4 of these angles, right? Because they're vertical angles. So let's pick one of them and talk about it. Let's look at angle DEC. So DEC, so this guy right here, that is equal to, again, half the measure of the sum of the intercepted arcs. So this angle here is intercepting arc DC, okay? And then his congruent vertical buddy is right here, and so this is the intercepted arc for his congruent buddy. So we're gonna add them. When the vertex is on the inside, you add. So plus arc AB. And that's how that works. All right, so you've got several, there's actually only 3 formulas, if you will, to remember. There's just several situations, but really you only have to know where the vertex is to know which formula to use. So let's take a look at a problem. Let's do an example. Here is our circle, and let's say we have a secant, and this is A, B, C, D, E, and this is 104 degrees, this is 20 degrees, and this, and it's called circle P. So you are given a diameter AB. You have that arc BD equals 20 degrees, and arc DE equals 104 degrees. And I labeled those for you. You're going to find angle C. Okay, so we know that this is 104 here. We know this is 20. we're looking for angle C. So angle C is equal to half of the, now it meets on, the vertex is on the outside, so this is going to be a difference. So arc EA minus arc DB. We know arc DB, we do not know arc EA. We can find it though. Here's a diameter, right? They tell us it's a diameter. A diameter splits the circle in 2 equal parts. I know it doesn't look equal from my picture, but half of a circle is worth 180. So we can do 180 minus, we know the 20, minus we know the 104. So that leaves us with 56. So this guy is 56 degrees. So we can plug everything into our little formula. EA is 56 minus DB is 20. We're going to do half, so that's 18 degrees. Not bad, right? Okay, let's do another one. Let's do a chord. Let's see, we've got chord. And here's A, B, C, D. This is 29 degrees, that arc. This arc is 47 degrees. Find, oh, and this guy here is Y degrees. Find Y. Okay, this is not, be careful guys, this is not a central angle. Notice that it doesn't sit on the center. It's inside, but it's not on the center. So we cannot say that this is 29 degrees or that this is 47. Are we clear on that? Do not make that mistake. It's easy to want to do it. We could find one of these angles. We know the arc measures, the inscribed arc, intercepted arc measures. So we could say angle, oh, you know what, let's call this E, not circle E, but this point is E. So angle BEC is equal to 1/2 arc BC minus, pardon me, plus arc AD. We could do that, and that would give us this angle here, and then we could find the measure for Y because they're supplementary. So let's do that. 1/2 of 47 plus 29. So that gives us 38. And then this 38 degrees here and the Y are supplementary. So 180 minus 38 equals 142. So Y equals 142 degrees. See how that works? Okay, so now that you've used kind of some simpler ones, let's do one that has maybe some more algebra to it. So you'll like this one. Oh, I need a eraser. Where's my eraser? Shoot, go get it. Okay, I shall use a clean tissue. Here we go. Here we go. Example. So let's say this is our circle. I'm going to do it nice and big so that we can see on the inside of it. And I've got a secant and a secant and a chord and a chord. This is A, B, C, D. This is E in here, and this is F. Okay, this is 65 degrees for that angle, 65. This is 24 degrees for that angle. This one is, arc is Y. We are going to find arc AB and arc CD. So we're going to look for those two arcs. All right, And so we said CD was y, let's let AB be x. And we're going to look for some relationships here. So x and y, oh, and the 24 have a relationship. So we could say angle F equals 1/2 of AB minus DC. So that would be 24 equals 1/2 of x minus y. Alrighty, then we also have this relationship here, 65. So that's angle AEB is equal to 1/2 arc AB plus arc DC. So that's 65 equals 1/2 x plus y. Two equations, two unknowns, guys. Algebra time. So let us multiply through by 2 on these equations. So that would be 40, I'm going to go down here. 48 equals x minus y. And then we can multiply by 2 here. 65 times 2, 130 equals x plus y. Oh, this is looking like an elimination, classic elimination. Look at that. We can eliminate the y's. So 130 and 148 is 178 equals 2x. So x equals 89. And then plug that back into your favorite here. Let's see, we could do, let's do 130 equals 89 plus y, so y equals 41. So arc AB, we said was x, so arc AB is equal to 89 degrees, and arc DC or CD is equal to 41 degrees. Okay? All right.